Hello everyone, this is Hating Tian. In this video, we are learning 2.8 inverse function. An inverse function undoes what was applied to the input value of another function. What is the meaning of that? We have learned that the function is like a machine. If you have a machine and you have an input part with it, we say f of, and here we plug in something. It's so ugly, the picture. Let me draw a better looking one. So here we say the input area, and then it will process, for example, this is 3x plus 2. Input the x, then it will give me the output. So this place is outputting something. If we say we are having an ATM machine, and the ATM machine we want to travel to the Europe. We need to get some euros. So we need the machine and we input the US dollars. So then it will give me the euro. So here is US dollar, here is euro. For example, if I put $1 in this machine, and then it will process and then the output will give me 0.9 euro. And now if I finish my traveling in Europe, I want to go back to United States. I still have some euro in my pocket. Then I will input the machine, maybe the same machine here. Then, for example, I input 0.9 euro, and this machine must give me $1. So this direction we call the f function. The input $1 and output 1 euro. And another direction we call that the inverse function is the opposite way. Input 0.9 euro and you got $1. So this is the meaning of the inverse function. So one is go to the forward, another one is backward. The graph of the function and the inverse function is symmetric along the y equals x. So this dashed line is y equals x. If I have the function f of x equals 2x minus 3, this is a blue straight line, then its inverse function is the red line. That's the line symmetric along the y equals x. And here we see if I have the x and I put it into the function f, I input the x into here, then I will get a y's value. Now for the inverse function, if I put the y in this inverse function, then I'm having the x. For example, I put the 5 in the function f, I'm having 7. I input the 7 into the inverse of f function, I'm having 5. The notation inverse of the function of f, we write it down like this. The -1 is not an exponent. The notation of this doesn't mean 1 over f. So we have learned that if I have 5 to the -1, that's 1 over 5. But now if I have a function, then here the notation doesn't mean the 1 over f. That's the inverse function of the function f. Okay, let's see. How can I verify whether two functions are inverse of each other? Since the inverse of function takes you back to where you started, the following holds. If f of x and g of x are inverses of each other, then f of g of x equals x, and the g of f of x equals x. If they satisfied these two conditions, so g and f, they are inverses of each other. So let's see the example. Let's decide if the f function and g function, they are inverses of each other. We must use these two. So the first condition is f of g of x. Can I show you that? Can we show that this one equals 0? So let's see. So f part inside the x need to be replaced by g of x. So 3 times when I see the x, now that is f of x minus 8 over 3 plus 8. Let's simplify the expression. 3 canceled. X minus 8 plus 8. So this is x, yes, but I still need to prove another combination function, that's g of f of x. So when I see the x in the g part, it needs to be replaced by f. So in the g function, all the x now is 3x plus 8, then minus 8 divided by 3. Then clear the parentheses, 3x plus 8 minus 8 over 3. Okay, we have 3x over 3, that is x. Now we have learned that I got x here. So f and g, they are inverses of each other. So how to write that? You can say the inverse function of f equals g. You can also say the inverse function of g equals f. Okay, let's see number B. If number B, f and g, they are inverses to each other. Let's say, what is f of g of x? Okay, so all the x here need to be replaced by g. So 5 times x plus 5 over 9 minus 9. And nothing can be canceled. We have 9. So 9 is the bottom. 5 times x plus 5 minus 9. I tried my best. I cannot make an x here. So they are not equal. How about another part? So g of f of x equals, so the g part, all the x need to be replaced by f. So when I see the x on the top, that's the 5x minus 9 plus 5. The bottom is 9. And we have 5x minus 4 over 9. This is not x. So f and g, they are not inverses to each other. Okay, let's see. Do all functions have an inverse function? That's a question. So we have learned in previous part that the relationship in which input value x result in unique output y. So x, y, they must be 1 to 1. What's the meaning of that? Just like the ATM machine we mentioned, if you input $1, then the output you got 0.9 euro. So you cannot say I put in $1 and then it gave me 2 euro or half euro. So that's not fair. Every time you have one unique input, you must have a unique output. And the opposite way, if I'm going to input 0.9 euro in it, I must have unique output. That's $1 in one US dollar. That means XY must be 1 to 1, or the function is 1 to 1 function. One unique x to one unique y, one unique y to one unique x. And we have learned that the inverse function, if the input is x, output is y, then its inverse function, the input is y, output is x. So the x, y, they are replaced by each other. Okay, let's see. If these three relationship are the function, or one-to-one function. Is the first one function. So 1x has two partner. So in 2.1, we mentioned that a function means 1x has one partner y. We cannot have two partner y. So this is not a function. And second relationship, yes, this is a function, but the 2x has one partner. This is not one-to-one relationship. Next one-to-one function. Yes, it is. One unique -2 mapping to -4, and the 2 is mapping to 4. 1 mapping to 2. Yes, this is one-to-one function. Only this kind of function has the inverse function. We can also use the horizontal line test. Let's see. It's very similar to the vertical line test. We need to draw a horizontal line. Let's see the first one, using the horizontal test to see if it has an inverse function. Let's test what's the meaning of this. Let's test if it is one-to-one function. If I have horizontal line and I have only one intercept. So that means it is a one-to-one function. 1y, 1 and 1x, or any intercept. That means 1y, 1x. If I have a horizontal line, I have two intercepts. Okay, what's the meaning of this? Two different x. For example, here is 2, here's -2. They are sharing the same y's value. For example, we say this is 1. That means this is not one-to-one function. If I have a horizontal line for number c, I have 3 intercept. This is not a one-to-one function, no inverse function. So no inverse function, but the first one has inverse function. And next one, if I draw a horizontal line, I have one intercept. Any horizontal line all has one intercept. Yes, this has inverse function. And let me ask you this: if I give you a graph like this, and then let you use a horizontal line, can you say this one has inverse function? Maybe some of you say yes. We only can find one intercept for each horizontal line. But inverse function means one, so that means we need to pass the vertical line test. So if I have vertical line test, I have two intercept. That means this red curve is not a function. If it is not a function, we don't need to use the horizontal line test because it is not function. We cannot say it has a inverse function. Okay, let's see. How do I find the inverse function? We have 3 steps. First, replace f of x with y. Second, interchange x and y. 3, solve for the y. 4, replace the y by inverse function of f. Okay, let's see the example. Find the equation for inverse function of f. The first step, replace f of x by y. Y equals 2x minus 1. Second step, swap the xy. So x comes to here, y comes to another side. 2y minus 1. Number 3, solve for the new y. And I need to solve the y, I need to isolate the y. So add 1 both sides. Add 1 here, add 1 here. We have x plus 1 equals 2y. And then isolate the y divided by 2 both sides. We have the y equals x plus 1 over 2. Because I know that this is equation, it's okay if I move the y to the left and all the other term to the right. Number 4, replace the y with the symbol inverse function of f. X plus 1 over 2. Okay, you can pause the video and think about it. Next one, first step, replace f of x with y. 4 over x plus 7. Second, swap the xy. X equals 4 over y plus 7. Number 3, solve for the y. Y is at the bottom. We cannot solve it. We need to move it to the top. That means we need to get rid of the denominator. Both sides I can multiply by y plus 7. So on the left-hand side, y plus 7 times x equals 4. Because we know that 4 divided by y plus 7, then multiply by y plus 7. Y plus 7, these two can be cancelled. Then we need to solve for the new y. Y plus 7 times x equals 4. I need to solve the y. Can I have x on the left-hand side? No. So let's get rid of the x first. Get rid of the faraway term first. So get rid of the x, y divided by 7. Divided by x, both sides. Divided by x. So we have y plus 7 equals 4 over x. Then get rid of the 7. Minus 7 both sides. Y equals 4 over x minus 7. Last step, number 4. Replace the y. And the inverse function equals 4 over x minus 7. So y, so some of students will get confused here. Y divided by x first here. Because x is, we are isolating the y. The x is far away from the y, so get rid of the x first, then get rid of the 7. Okay, let's solve the next example. F of x equals x plus 4, all divided by x minus 3. First step, y equals x plus 4 over x minus 3. Number 2, x equals y plus 4, y minus 3. And number 3, solve for the y. So we are solving for the y. Y is at the bottom. We cannot solve it. So both sides multiply by y minus 3. Y plus 4, y minus 3 times y minus 3. So these two canceled. So y minus 3x equals y plus 4. We need to combine all the y together. We have y on the left-hand side and right-hand side. How to combine them? One y is in the parentheses. We need to rescue this y from the parentheses, clear the parentheses. We distribute the x in the parentheses. We're having xy minus 3x equals y plus 4. And then we need to combine these two y's. So if I move the y to all of the y to the left-hand side, I can subtract the y both sides. Minus y here, minus y here. We're having xy minus y minus 3x equals 4. And then get rid of the x. We can add 3x both sides. Add 3x, add 3x. We have xy minus y equals 3x plus 4. Then we can pull out the y because the y, so they both have the y term. Y times x minus 1 equals 3x plus 4. Now we can isolate the y by dividing by x minus 1. X minus 1 divided by x minus 1, y equals, these two canceled, 3x plus 4 divided by x minus 1. Now y need to be replaced. So the inverse function of f equals 3x plus 4, x minus 1. Okay, let's see next example. Let me erase this. Okay, next example, let's use the same method. First, replace f of x with y. Y equals x cubed minus 1. Second, swap xy. X equals y cubed minus 1. Number 3, solve for the y. Isolate the y. We can add 1 both sides. So y cubed x plus 1 equals y cubed. That also means y cubed equals x plus 1. And then both sides, we can cube root both sides. Cube root both sides, cube root of y cubed equals cube root of x plus 1. When we cube root both sides, we don't need to worry about positive or negative solution. So y equals cube root of x plus 1. So number 4, replace the y. We found the inverse function, x plus 1. So this is the inverse function. Okay, let's see number 57. Number 57, it gave us a restriction of the x. Will that be helpful when we are solving it? Okay, let's solve it by the 4 steps. First one, y equals 5x squared minus 2. Second, swap the xy. X equals 5y squared minus 2. And then isolate the y. We can add 2 both sides. X plus 2 equals 5y squared, and then divided by 5 both sides. So x plus 2 over 5 equals y squared. And we square root both sides. So let's swap these two from each side. So square root of y squared equals, here you must be careful. We have learned you square root a variable, you must have positive or negative solution, right? Square root of x plus 2 over 5. And then we have y equals positive or negative square root of x plus 2 over 5. Is that my solution? Can I write it, replace the y with the inverse function of f? No, we have learned that in the function f is one-to-one function. Also, the inverse function is a one-to-one function. Now, if I input the x value here, then I'm having 2 output y's value. Okay, so that means the inverse function is not a one-to-one function. And so if I only have positive solution, yes, it's one-to-one function. Or I only have the inverse negative function, it is inverse function. But we have 2 y's value. How to decide if this one has the inverse function? Let's see here. The given information is x is greater than or equal to 0. Let's see. X is the domain or the input. Then here f function is output. Now, this one is the inverse function. That means this y is the x from the f function, because we have learned the inverse function from the x to the y. And if the inverse, this is f function, if the this is function f, and this inverse function is from y to x. Okay, so the x is the domain for the f function. And then for the y part, from the y to the x, now this inverse function, they have, so the range is the domain. Okay, that means this x and this y, they must be the same and they have the same interval. All right, now from the x domain, x is positive solution or greater than or equal to 0. Then for, okay, so messy. So for the y part, the inverse function also need to be positive. Yes, that means I need to have positive solution greater than or equal to 0. I only keep the positive sign. Okay, then I can replace the y by the inverse function of f. Remember that if it has a restriction here, that means I need to be more careful when we are solving the y. The y must have the same restriction like the x in the function f. All right, this is a tricky question or very good question. Okay, let's see number 60. Number 60, f of x equals cube root of x minus 8. We follow 3 steps. First step, replace f of x with y. Second step, swap xy, x equals cube root of y minus 8, and then solve for the y. If I'm solving for the y, I need to cube both sides, then get rid of the cube root. So let's cube root both sides. Oh, sorry, cubed both sides. We have x cubed equals y minus 8 because cube root canceled. Then isolate the y, we can add 8 both sides. So y here, x cubed plus 8, y equals x cubed plus 8. Then we don't need to worry about the domain or range because it doesn't mention at the beginning of the question. So the y and also these two, they are all the one-to-one function. So number 4, replace the y by the inverse function of f. X cubed plus 8. Okay, let's move on. When given the graph of a one-to-one function, how can I graph the inverse? If I know this function is one-to-one, it's past the horizontal line test, how to find its inverse function graph? We have learned how to find the inverse function by the 4 steps, but now how about the graph? We have learned that if I have a point on the function f, x comma y, then its inverse function, we just swap the x, y. We got y comma x. That means if I have 1 point from the function f, then I switch the x, y position in the coordinate notation, then I can find the points on its inverse function. Okay, let's see. Let's swap them. We have 4 key points on the function. For example, I call them function f. Then its inverse function, they must have this 4 key points. They are, so swap these two, is -5, -5, and -3, 0, 1, 2, and 3, 5. So let's find these key points. So -5, 5, yes, still this point. -3, 0, -3, 0 is here. 1, 2, okay, 1, 2 here. So 3, 5, 3, 5 here. Then we line them up. This is the inverse function, and you see it's symmetrical along the y equals x. So let's see next function. So we see the function provide us 4 key points. So you can swap x, y, so find the key point for its inverse function. So the key point there, so this is key point. So we have -3, -5. And second point is -2, 0. So second point here. Third point is -1, 3. The fourth point is 4, 0. We say 0, 4. Let's find these 4 points. Use different color. -3, -5. -3, -5 should be here. And -2, 0, -2, 0 here. And -1, 3, -1, 3 here. And 0, 4, 0, 4. Okay, I need to line them up. Okay, this is a graph. And you must see this graph is symmetric along with the f function, along which one? Y equals x. If the graph you have found is not symmetric along the y equals x, you may make a mistake. So you need to check your steps. Let's see, next one. Let's find the inverse function of this function. It has 3 points. So they are -3, 0. It doesn't show us the points, but we know the coordinate of these 3 points. So we can put them here. So the 3 points, they are -3, 0, -1, 2. And last point is 5, 3. So the 3 key points from the first one is 0, -3. Second key point is 2, -1. Last key point is 3, 5. Let's plot the key point. 0, -3, 0, -3 is here. 2, -1, 2, -1 here. 3, 5, 3, 5. And let's line them up. Okay, you also need to see, sorry, pause 3, 5. And from the graph, you can tell that these 2 functions, they are symmetrical along the y equals x. If you have a line, which is y equals x. So these 2 graphs, they must be symmetric along the y equals x. Okay, that's all about 2.8, and we finished the unit 2. So please be prepared for the exam 2, and please do your quiz, and also let me know if you have any question. Okay, have a good day. Bye.